have your multiple components. Okay, so you do set, okay, I want this component to be placed right in the center of the board. I want my USB connector at the edge of the board. I want my temperature sensor very near to my processor to monitor my processor temperature. I want my D dash, which has to be placed very close to my processor. Okay, I need to have the memory which has to be placed. I have an analog section which has to be placed a little far away from my high speed signals. Okay, so anyhow, why you need to place the analog section far away from the digital section? This will be emphasized or discussed in detail by upcoming sessions. Okay, so all these things, and how you will connect this, how many layers of PCB you need to have. Okay, all these things will be documented in the PCB constraint document. Okay, this will be done by a hardware engineer most of the times, and it will be an input to the PCB design engineer. So it's a very good design practice to have a PCB constraint document drafted. In my career, some of the teams or some of the people, okay, don't or ignore drafting the PCB constraint document, and they juggle around, okay, and they have heated up debates with your with the PCB engineer and hardware engineer. It is good to it's good design practice to have a PCB constraint document drafted, and you capture all your requirements, what your PCB engineer has to do it, because you cannot all the time, you cannot sit with your PCB design engineer to design it. Anyhow, I'm not making PCB design engineer low. PCB engineers also experts. Okay, so but it would be good for PCB engineer if you are giving a PCB constraint. It will make PCB engineers vision clear. Okay, so that based on your PCB constraints, he will come up. He will design it. Okay, so mechanical. If you see one particular one on the PCB design, you have mechanical input DXF. So why mechanical? Okay, so you have, when you have designed your PCB or anything, okay, it should get into your, it should fit into your system. Okay, you will have a mechanical enclosure. Let's take your TV. Okay, so you have your screen on, behind it you cannot see your PCB okay, outside. So it will be residing inside or in between. Okay, so on top of it you have your plastic enclosure. So mechanical engineer will design that. Okay, so he will make sure that there should not be any components or any tall components that should not hit your mechanical enclosure. It's not just limited. Mechanical engineer's work is not just limited to that. If at all, if you have any kind of components which are heating up, like some processor or something, you need to have a heat sink. Okay, so but you still have a limitation. So mechanical engineer will help you to design a heat sink for your processor or anything. But it goes in hand. Hardware engineer, PCB engineer, and mechanical engineer also does this. And sometimes without help of any PCB heat sink, mechanical engineers will be expertised in preparing the enclosure where some vents will be provided, so that natural cooling or normal ambient temperature itself, the temperature will be maintained. Okay, that is one thing. And it's not just limited to this. So mechanical engineer has a lot of scope here. Okay, and coming to the design release. Okay, so design release includes your final schematics, final BOM. So it's not a bomb, atom bomb. It's a BOM, stands for bill of materials. So what is this bill of materials? Bill of materials includes what are the components, like resistors, capacitors, your ICs, your sensors, your actuators, okay, and your PCB. Okay, all these things will be listed out in the BOM. Okay, this will be a one single deliverable for any market, for any person, a purchase person. When you share your BOM, okay, just it's not hardware responsibility to buy all components. So there will be from the financial team or some other teams, okay, who will be taking care of purchase of these components, or strategic sourcing group. Okay, and in case of any product based organization, when you share this BOM, when you have this information documented, what is the resistor, let's say I have a 10 ohms resistor, and the manufacturer part number and the manufacturer name is Kemet, okay, or Murata, or from Vishai. Okay, so all these things, if you have documented how many quantities you need, okay, if you list out all these things in the BOM, then it will be easy for a sourcing person to purchase and keep the things ready for your proto build. Okay, and final Gerber packaging. Okay, so this will be more emphasized. Okay, Gerber in the sense like this will more emphasized by the PCB engineer. Okay, this is related to your PCB release. Okay, when you draw your PCB at last, what are the layers? Okay, how the all these things will be taking care in the Gerber packaging. Okay, and obviously your design documentation and manufacturing documentation. So manufacturing documentation includes like how you need to manufacture. You need to go for what type of solder profile you need to use. Like what is it like, to what temperature you need to maintain to solder this particular components, all those things, even ICT in circuit. Once you manufacture, to ensure that okay, you have properly manufactured. Okay, so you do kind of some testings in the manufacturer, so that to quickly tell okay, my board is manufactured properly, components were assembled in the right manner. Okay, so all these things will be taken care during manufacturing, and all these things has to be documented in the manufacturing document. Okay, and coming to the PCB fabrication. So PCB fabrication, so I think most of the people here are aware about PCB. So PCB stands for printed circuit board. Okay, it's not, maybe freshers might be seen some general purpose PCB. If at all, if you have opened any of the electronic systems, okay, you would have seen a kind of a board, okay, a plate or something, okay, where you have components and some interconnects. That is what we call it as PCB. Without, if you don't have any components placed on that, we call it as PCB. If you have the components placed on the PCB, then you call it as PCBA. It is printed circuit board assembly, PCBA. Okay, so PCB, before you assemble it, have the PCB, how you will manufacture. So it's not hardware engineer will get the material and do the fabrication. So hardware engineer and PCB engineer and SI engineer will come up with the PCB stack up and all these things. So there will be a fab houses, fabrication houses who will be fabricate, okay, based on the layer count. Let's say 12 layers, 16 layers, 4 layers, 6 layers. Okay, it's not just limited to one single PCB. You may be having a flex cables or rigid flex cables. Okay, so all these things will be covered. So few of the just to out of curiosity, I'm just mentioning some of the PCB fabrications which I have dealt with. Sanmina, TTM, via systems. These are the major market leaders, major market leaders in terms of PCB fabrication. And there are small players in the market as well. Even there are PCB fabrication houses in India also, but not to a larger extent, I believe. So Samina is from China, I believe, and TTM is most probably from US, I guess, but I'm not sure. Okay, and PCB assembly. Okay, PCB assembly, you have so many assembly houses. You can even find in Bangalore or in India, some bigger cities, metropolitan cities. Okay, so what PCB assembly does is they will be having some automated machines. Okay, they will be placing automatically, some robotic arms will be there, which will be automatically pick the component and solder it. So don't expect that all the PCBs which you have, which you see in your product, are hand soldered. Okay, some of the components will be hand soldered, and some of the components will be done through an automated machine. Okay, so coming to the next testing phase. Okay, yeah, I missed to emphasize on the two other tiles over here. It is software and hardware interface document preparation, which in short we say it as IRS, interface requirement specification. Okay, so what is this? Okay, so as I said, if you have just a processor, and if I hardware engineer, if I put and I have designed my circuit, it's not just goes with that. You need to load some kind of software code into that to get it working. Okay, so how you need to configure it? Okay, there will be some key registers or key parameters that needs to be set in the software. through that the expected output hardware or expected output will be met. Okay, so let's say for an example, okay, so you need to you have a sensor. Okay, so your sensor will be giving, you have a temperature sensor, you have a thermistor. Okay, it will be sensing the temperature in terms of resistance. Okay, if it is, if at all, if it is a NTC, negative temperature NTC, so your temperature will decrease when your resistance will decrease based on your temperature. So when it, so and you will be seeing the voltage drop across it. So what voltage is associated with what temperature? Okay, if at all, if you read if you at all, if you measure a 1 volt drop across your thermistor, okay, it may refers to 1 degree or 25 degrees centigrade. So all these things you will document it. Okay, and you put it into your interface requirement specification. So interface requirement specification is not just limited to this. There will be some power kind of power sequencing, how you want to interact your, how you want to power up your board, which and all interfaces has to be up during the right after your initialization, and how you need to have your, let's say if you have a touch screen. Okay, so when your touch screen has to turn off, okay, should you turn it off after 5 minutes or 1 minute or like that? So how you like, which, if you press which button, if you press this particular button, if you press once, okay, your screen should lock. Okay, if you do a long press for this much duration, your battery should power down. So all these kind of things will be documented in your interface requirement specification. Okay, so even yes, in some companies they do skip this and providing. So as I said, like PCB constraints, this is also an input document for a firmware engineer or a software engineer. So it's a good design practice to document all these things in your design. Okay, coming to the testing phase. So before you need to start your testing, so you need to have a goal. Okay, you need to have a plan. Okay, how you will test it. It's not just like okay, I need to test it. So if you don't know what needs to be tested, what are the testing, what is the test criteria, okay, so then there is no meaning in it. So all these things will be taken care in the test plan. Okay, so you will tell, okay, I will be testing my 3.3 volts, okay, with an oscilloscope or a multimeter, and I will test my power supply output using a current probe or a multimeter or whatever it is. So all these things you will document. And if, when I'm measuring my 3.3, obviously your, when you say 3.3 volts or 5 volts, okay, obviously it will not be, ideally it will not be 5 volts, it may be 4.95 volts or 5.5 volts or like that. So all these things you will be setting your test criteria and the pass criteria. All these things you will be documenting in your test plan. Okay, let's say if you take an I2C interface, so what is the clock speed that you have set, and are you like, what is the voltage levels that you have designed for? Are you meeting that requirements? Amplitude, are there any undershoots or overshoots? Okay, so all these things will be documented. Okay, so this will be like a test plan. So and this is also a deliverable. Okay, you need to get this approved before you start your testing. Okay, so some of the organizations, so I'm not seeing it in a negative context, okay, but it's a good design practice to have your test plan drafted and approved before you start your prototype testing. Okay, so coming to the last 3 points over here. So board bring up. Okay, so we have something in detail. Okay, in the upcoming slides, I believe. So board bring up. Okay, when you get your prototype built and get in your hand, just like that, you should not turn it on. Okay, so you need to do some kind of some few activities on the board, whether are all the components which you have intended in your design are placed properly or not. Okay, are there any miselements of the component? Okay, and you see, are the proper components are placed in a right orientation. Let's say you taken a polarized capacitor. Okay, you will be having a positive terminal and negative terminal for that. So if at all this polarized capacitor is placed ulta, means negative terminal was placed, was connected to positive pad, and then the positive terminal was connected to a negative pad. So definitely it will malfunction the device, and sometimes it will, when you don't check all those things, definitely when you power up, your device will get malfunction. Based on the complexity, your board will get damaged. Okay, and definitely it will lead to some kind of hectic situation during your bring up process. So all these things will be taken care of during board bring up. So once you power up, when after doing all these things, so you do check your impedance measurement of your board. Okay, let's say if you have some power rails. Okay, power rails in the sense power supplies. Okay, and your board, some 3.3 volts, 5 volts, 1.8 volts. So you need to check, are there any short? What is the resistance between your VCC and ground? Okay, so if at all, if you see any short, that means your VCC and ground has got short. And when you turn on your board, definitely your power. So your, when it is short, that means you have, it is showing zero resistance. Okay, that means V is equal to V is equal to I is equal to V by R. Okay, so it will draw infinite current. Okay, and definitely it will damage your board. Okay, all these things we do take care during bring up. It's not just limited to this. There are a few other things, and it is design to design dependent. Okay, so integration testing. What is this integration testing? So you have your hardware board done and designed. Okay, and you have done the bring up. So you need to load some firmware or code into that and see the test. Okay, if I have the production firmware or how it will behave. Okay, so integration testing is not just limited to putting the firmware into hardware and testing it. So you have to see in a holistic view. Okay, so you put your firmware, everything, and put your assembly your system into a mechanical enclosure. If at all, if it is an electromechanical product, okay, your product has to actuate some kind of sense, do some sensing and actuate some kind of motors or some kind of robotic arms. So all these things will be taken care during integration testing. So once you have everything done and integrated, then you go for verification and validation. And we'll discuss about this in detail in the upcoming slides. Sorry, I have taken much time for this slide, because though the like we need to emphasize on each and every point over here. So I didn't cover about pre-SI and post-SI and power integrity. So this will be this is an in detail topic which will be taken care by SI or PI engineers over here. Okay, I could hear some.